thank you for coming back to my live stream. Today is day 10. Currently I am solving this CSES problem set, and as I have solved this introductory problem and currently solving this section, sorting and searching. Yesterday I tried to solving this collecting numbers 2 and playlist. I couldn't solve this collecting number 2 and solve the playlist, but probably today I only solved one problem, and we'll stop this live stream because I have to go for sleep earlier today because tomorrow I have classes early morning and I don't want to miss any class, that's why. But let's see which one I can gonna solve. I want to solve this collecting number 2 by myself, so I haven't checked anything after the live stream. Yesterday live stream, any solutions? Yesterday we have checked, I think, the how this solution is going to be look like, and it was really somehow a complicated one, not the easiest one like I tried solving here. So today I will not be solving this one. I only was solving one, so let's move on. Probably one or two if I can solve these towers and traffic light board. Let's see if I can. If I can, I will be doing, like, I won't be extend this live stream more than 1 hour. This is my goal today, so we'll solve as many I can during this hours. So today I will be talking a lot of I only focusing on solving. You are given n cubes in a certain order, and your task is to build towers using them whenever two cubes are one on top of the other. The upper cube must be smaller than the lower cube. You must process the cubes in the given order. You can always either place the cube on the top of an existing tower or begin a new tower. What is the minimum possible number of towers? You are given n cubes in a certain order. Your task is to build towers using them. Whenever two cubes are one on top of the other, the upper cube must be smaller than the lower cube. You must process the cubes in the given order. You can always either place the cube on the top of an existing tower or begin a new tower. What is the minimum possible number of towers? The first input line contains an integer n, the number of cubes. The next line contains an integer k, 1, k2 and kn, the size of the cube. Print the one integer, the minimum number of towers. I think to make this minimum number of towers, I always can choose like this. If I can always choose, I can start from the 3 and choose the all elements that are less than 3. Then in second one, I can start from 8 and choose all elements that are less than 8. And I can do this for forever. But what if like numbers are 1 2 3 4 5 8? Okay, I think I can choose like this. I can start from the left one and find last is 3, so I will find that there are more than 3, so that is 8. Now I will be find more than 8 numbers. Yeah. Okay, I think I got this answer. This is a greedy solution. The solution I am thinking was greedy. Let's copy this. this should definitely work. Okay. What this solution is basically doing here, I am first I have taken the size of the cubes and the order that given in this question, and I have taken a multi-set, and this is no need of priority queue here. I was trying to do something else, that's why I have make this priority queue, but since in this question there is no need of priority queue, the way I am I have implemented here is using multi-set. Let me remove this first. Okay, it is working, right? Here I have taken multi-set. Using multi-set, what we can do is that we can insert this queue into the set. If it is empty, we insert this. This is basically the first the zeroth position we insert here, because in zeroth position there is no other option. This was a greedy solution because we take the first one that is in the order, we stack it in where it is possible, and in the second time, if it is possible in the first one, I have put it. Otherwise, I have taken another stack. So in multi-set here, here I have done the upper bound search. What upper bound search is done in this set, multi-set, it will find the first element that is more than the given value. Here I have put cube, so the value of the upper bound will be the first element that is bigger than the first index of the element, that where the value is greater than the cube. And so this is how I can find that there is a cube exists, there is a value exists where there is a value exists which value is bigger than my current stack current cube size. So therefore I can put that cube size into that into that stack, because by doing that it will be the lower cube will be the bigger than the upper cube. So I can remove that lower cube from the multi-set and insert this the new cube size, because I have no need of the previous historical stack values to know whether I can insert the latest cube size. I only need the just the previous one, that is just before the upper one that is in the stack. So I can determine with that whether I can stack in that I can stack this cube into that stack or not. So here I am doing, if there is no upper bound left for that cube, I simply insert another cube. That is, I created another stack in this stack list, and I will be continuing with this stack list. And otherwise, if I found that upper bound, I have erased it and then put that cube instead of that upper bound. And after doing this for loop, I will be getting the answer will be the stack size, basically how many stack are there. So basically I performing the stacks just but don't have my historical data. So why multi-set? Because I cannot stack 4 into, if the previous cube size is 4, so I have to create another stack which size is also 4. Therefore there should be it cannot be unique elements. So that's why I have taken here multi-set. It was kind of nice if you know this idea, but sometimes it took time. You develop some other ideas, then you find. But yeah, I just really like that how you can use this data structure to solve your solutions. Okay. Now we're left with traffic light. Traffic lights. There is a street of length x whose positions are numbered 0, 1, x. Initially, there are no traffic lights, but n sets of traffic lights are added to the street one after another. Your task is to calculate the length of the longest passes without traffic light after its addition. Consider a game where there are n children numbered 1 to n in a circle. During the game, every other child is removed from the circle until there are no children left. In which order will the children be removed? Consider a game where there are n children numbered 1 to n in a circle. During the game, every other child is removed from the circle until there are no children left. In which order will the children be removed? Oh yeah, Josephus problem. This is called Josephus problem. There is remove word, but I have found somewhere that there is a n something in a triple number from 1 to n in a rounding table, right? And why there is no 14615 in a circle during the game? Every other child is removed from the circle until there are no children left. Okay, every other is like 2461537. This is famous problem, I guess. Okay, today I have solved this one, towers problem. As I said, probably today I going to resolve only one problem, or I will stream not more than 1 hour. It was already 40 minutes has gone. So since if I started on another problem, it probably go more than 1 hour. Therefore, that's why I am thinking for today will not solve more than now, and no more questions. We'll come back tomorrow and try to solve and more than two or two at least two problems. And these are problems are with the name I can see that these are mostly the standard problems, because and most of them probably needed to have some knowledge about uh, knowledge or trick to solve these questions. So if I couldn't solve in a bounded amount of time, I will be saying the solutions, because I don't think that uh, wasting time to solve by myself some questions that are standard and it really need to find something tricky stuff. So um, instead of spending time here, I can spend more time in the another similar type of question that needed in this type of trick. So I so that I can think those directions. And mostly this problem will be the more I will be spending more time, because these are things, even though I say I will be I even I have said the I will seek the answers, I will be spending times to understand why the solution is like that, because most of the time I couldn't uh, find I couldn't solve myself after seeing the solution. So those are the problem with dynamic problem I am facing it. And similar to the graph algorithms are probably look like standard if I know the theories and all of those. So we'll also solve this out as we go along the way. So is there any update on code process? I think code process is updated all this like max or the title, and I don't making any sticker. I am not good at those things. I am thinking solving problems with that have less than 700 or ratings. It would be better for me if I solve this. There are some few problems that I didn't solve, which are 1600, 1100, 15, 11, 9000, 15, and here 14, 10,000, 17, 16, 1200, 1700, 1500, 1100, 1200. So I have to solve these all. I should give more time to solve all of this. Here also there are few questions that I didn't solve, 1700 problems, 1400 problems. These are kind of solving type of problem for me. I have to give time for this as well, because here also there are a lot of questions left. Here 1500 problems, 15, 1600 problems, 1600 problems, 1400, 1700, 1700 problems. So once I have solved this problem set, I will be going through with those problems. Thank you for watching to this stream. Now I am going to stop the stream. Thank you. Signing off. We'll be meeting tomorrow.